So next I want to talk about some key challenges in NLP, answering the question, why is NLP hard? And we're actually going to focus on one particular problem, namely the problem of ambiguity, which is seen time and time again in natural language problems and applications. So to illustrate this, we'll take an example sentence. This is actually from Lillian Lee. And the sentence here is, "At last, a computer that understands you like your mother." And I think this was taken from some marketing blurb for a natural language understanding system sometime back in the 1980s, I believe. The problem, of course, with this sentence is that it is actually ambiguous. There are at least three readings or interpretations of this sentence. So let's go over that. So the intended meaning was probably this. It's saying that the computer understands you as well as your mother understands you. But if you look a little harder, you'll see that there are a couple of other possible interpretations. So one is that the computer understands the fact that you like your mother. So at last, a computer that understands you like your mother. Under another interpretation, the computer understands you as well as it understands your mother. So at last, a computer that understands you like your mother. And then, even if we look at these two interpretations, 1 and 3 alone, there's the question of whether this means, does the computer understand you well? Is the context, does your mother understand you well? Without knowing that, you can't answer that question. And we have a similar ambiguity here. So ambiguity also occurs at the acoustic level. And this is a key problem in speech recognition. So again, if we come back to this example sentence, then from a purely acoustic point of view, this sequence "lie cured" can be confused with other things. So, for example, "lie cured" is a valid sequence of two words in English, and acoustically these two things might be quite confusable. Of course, this is much more plausible as a sentence of English than this, but nevertheless, if a speech recognizer was to rely on acoustic information alone, it's going to have to deal with all kinds of ambiguities like this, where two words or two sequences of words are confusable. It's interesting to note that many of these ambiguities manifest themselves at the syntactic level. What I mean by that is they manifest themselves in the parsing problem that I showed you earlier. So different structures at the parsing level, again these are these hierarchical parse trees I showed you, lead to different interpretations. So in fact, these two interpretations where the computer understands you as well as it understands your mother versus it understands the fact that you like your mother, actually correspond to two quite different syntactic structures. So one of the key problems in natural language parsing is essentially disambiguation, choosing between different syntactic structures corresponding to different interpretations. Here's yet another level of ambiguity in language. This is at, roughly speaking, what we might call the semantic level. And this is an instance of what is often referred to as word sense ambiguity. So if you look at it in a dictionary, if you look at many words in English or other languages, they have multiple different meanings depending on the context. So again, mother was a word in that sentence I showed you previously. If you look in a dictionary, you'll find the conventional, or rather the frequent usage of this word. But you'll also find a much less frequent usage, which is given here. And a natural language processing system will have to disambiguate between these two meanings. Here's a bit more on word sense ambiguity. So if I take the sentence, "They put money in the bank," it's pretty clear here what we mean by bank, but there is an interpretation where the money is buried in mud. So we're going to have to disambiguate this word to work out which of these interpretations is intended. Here's another example. "I saw her duck with a telescope." So this sentence is actually ambiguous in multiple ways. I could be looking at her duck using a telescope. I could be looking at her duck who has a telescope. You can go through many other examples. But there's a key word sense ambiguity here, which is the word duck can refer either to the animal or it can refer to the process of ducking, the verb to duck. And that leads to two quite different interpretations here. So yet another level of ambiguity is at the discourse level. And what I'm going to show you here is an instance of anaphora. This is the problem of taking a pronoun, for example, she, and resolving it to the entity that it refers to in the world. So let's again assume that we have our sentence, except here I have Alice says as the start of this sentence. And let's say the continuation is, but she doesn't know any details. Actually, I have two possible continuations here. But she doesn't know any details, or but she doesn't understand me at all. So she could refer to two different things. It could refer to your mother, or it could refer to Alice. And so there's an ambiguity here that we need to resolve. We need to figure out which one of these two entities in the past she is referring to. And actually it's going to differ for these two cases. If I say, but she doesn't know any details, by far the most plausible interpretation is that she is referring to Alice. But if I say, but she doesn't understand me at all, in this case, by far the most likely interpretation is that she refers to your mother. So this is, again, actually a very challenging problem, taking pronouns and figuring out what entity they refer to in the past discourse. So the final thing I want to talk about in this lecture is the content of the course. What will this course actually be about? And so we're going to cover several topics in this course. One thing we'll look at is the basic NLP subproblems that I mentioned earlier. Problems such as part-of-speech tagging, parsing, models for word sense, disambiguation, and so on. A second major focus of this talk will be on machine learning or statistical methods for natural language processing. So machine learning techniques have become extremely prevalent for all of the natural language applications and problems that I described earlier. As one example, modern machine translation systems are trained automatically from vast numbers of example translations. Statistical methods are used to induce dictionaries and other kind of models for that translation problem. So we'll talk about many basic mathematical or computational models based on machine learning techniques applied to language. These include probabilistic context-free grammars, hidden Markov models. We'll talk about estimation and smoothing techniques right at the start of the class. We'll talk about a famous algorithm called the EM algorithm, which is widely applied in speech recognition and also machine translation. We'll talk about a very important class of model called log linear models later in the class, and so on. And finally, we will talk about various applications, including information extraction, machine translation, and possibly natural language interfaces. So here is a syllabus for the class. We're going to start off with a problem called the language modeling problem, which will be in some sense a warm-up, introducing many important ideas, particularly an idea called smoothed estimation. We'll then talk about tagging problems, such as part-of-speech tagging and named entity recognition. And we'll talk about hidden Markov models, which are a key model for these tagging problems. We'll talk about the parsing problem that I described earlier, and we'll talk about models for that problem. We'll then have a few lectures on machine translation, where you'll see more or less from the ground up how we can build a modern machine translation system. Next, we'll talk about log linear models and discriminative methods. These are a key model in statistical natural language nowadays, and they're applied to several problems which we'll go over in these lectures. And then finally, to finish up, we'll talk about semi-supervised and unsupervised learning for NLP, which is a very important topic and a huge area of current research. So in terms of prerequisites for the class, coming into the class, you should know some basic linear algebra. Some basic probability will be key, so you should know what discrete distribution is, what a random variable is, and finally some basic knowledge of algorithms in computer science. And secondly, there are going to be some programming assignments on the course, so you should have some basic programming skills. For example, if you can program in Python or Java, that should be plenty for this course. One of these two programming languages would be plenty for this course. Finally, in terms of background reading for the course, there are a couple of resources. So over the years, I have developed some fairly comprehensive notes for many of the topics, actually for all of the topics you'll see in the course. So if you go to my webpage, you'll find a link to those notes, and they should be very useful as background reading for lectures. And in addition, as additional context, I'd recommend Jurafsky and Martin, Speech and Language Processing textbook. This is by no means essential, but if you want to read more around the subject, this could be very useful.